myself Ankita Tiwari from LG Institute of Engineering and Technology from IT ICT department. I am going to take the session on module 1, that is of digital fundamentals, having the topic as number system. Start with the first type of conversion, that is binary to decimal. Now 4 types of base system, okay, and the conversion will be always, it includes every, means if we are taking one type as binary, so other can be decimal, hexadecimal, octal, or initially decimal. Okay, so that 4 types includes the conversions. So we'll start with the first conversion as binary to decimal. As you can see here, we'll take an example with a number. So here I have taken binary number as 10101. Okay, so that number will be represented with bit position. Okay, so here we have taken 5-bit number. As you can see, 10101. So here, how many bits are there in this question? It is 5. So bit position is always start with LSD part. So LSD is 1. That bit position include the first LSD as 1. After moving forward, then 2, then 3, then 4, and then 5. Okay, so these bit positions will give the LSD part and the MSD part in order to move from LSD to MSD. Okay, now when we want to convert any number system to other number system, for that we should know the source base and the destination base. So here, every time whenever we want to convert from one base to another, we have to keep in mind, when we are doing the conversion, the number which is taken as source will have which base. We have to multiply that number with the source base. So here we have to multiply with the base, and here the base is given as binary. Binary is with the base 2. So here we will do the multiplication with the base 2. And the multiplication will always start from LSD. Okay, so here I am showing you the first bit position with the MSD. Here MSD is given as 1. Okay, so that one will be taken and that will be multiplied with the base with the power. Here as you can see, 5th position, and we are starting with 0. So 5th position will have a number as 4. Okay, so here 1 into 2 raised to 4. After that, the next number after 1 is, from LSD it is 0. As you can see, that's 0. So that 0 will be multiplied with the 2 with the value as or power as 1 decrease order, that is 4. After 4 it will be 3. So after that we will take a number that is 1. That 1 will be multiplied with the base 2 with the power as 1 decreasing order, that is 2. After that 0 into 2 raised to 1. Okay, and the last LSD digit is 1. That will be multiplied with the lowest value, that is 1 into 2 raised to 0. Now we have to do normal addition of this multiplication value. Okay, so in this we will get an answer as 1 into 2 raised to 4 means 16, plus the third position 1 into 2 raised to 2, that is 4. So 16 plus 4 is 20, and the last value is 1 into 2 raised to 0, that is 1. So 21. So we'll get an answer as decimal 21. So this is what binary. Next type of conversion is hexadecimal to decimal. So here the source base is 16. So we'll multiply that number with the base 16. So here I have taken an example as 5A9. Okay, so 5A9 is my number that we have to convert to decimal. Okay, so here the bit positions that we are taking here is 3. As you can see, we are taking an example with 5A9, so it includes 3 bits. So 1, 2 and 3. With the bit position we will multiply the numbers. Okay, now this is with the base 16, so we have to do the multiplication according to that. It includes the first bit position we will take as 5, and it will have third bit position. So third means its power will be 2. Okay. Moving forward, A. So A is actually 10. So that will be multiplied with the base 16 with the power 1. Moving forward, the last value, that is 9, with the lowest value, that is 0. So 9 into 16 raised to 0. So we'll do the normal calculation, that is addition of these numbers, and we'll get the decimal value as 1449. Moving forward, the next type of conversion is octal to decimal. Now octal to decimal, we will take an example with 645, that is octal number. Okay, here the bit positions are 3. As usual, 3 numbers are there, so 3 bit positions. Okay, we will multiply with the base, it's octal. So octal base is 8. Okay, so here the first value that will be taken here as 6. So that 6 will be multiplied with the base 8 and with the power 2. The same thing after 6 we will have 4. So 4 will be multiplied with the base 8 with the power 1, and the last value is 5. So 5 will be multiplied with the base 8 and with the power 0. And we will do the normal mathematical calculation and we'll get the answer as decimal number 421. This is what octal to decimal is. After octal to decimal conversion, we are having decimal to binary. Now here the position is changed. Here the source is changed and the destination is changed. Okay, so we'll start with decimal to binary. Okay, so here the same thing, the number is divided into 2 parts, that is LSD, that is LSB, or the MSB, last part. Okay, so we'll start with always start with LSB. Okay, so here we'll take an example with decimal number 39. Okay, so that 39 will be taken. Okay, that 39 here the method includes, in binary to decimal it was multiplication, in decimal to binary it is division. Okay, so the method includes division. Now division includes 2 things, quotient and remainder. Okay, so in every division we'll get 2 values, that is quotient and remainder. Okay, the quotient value which we are getting in the answer will be furthermore divided till the number is less than the divisor. Okay, how we will take that number? So we'll take an example. We have taken 39 as the number and now we will divide the number. We'll get the 2 things, quotient and remainder. Here the quotient we are getting is 19 and the remainder we are getting as 1. So that 1 is our binary number, but that quotient we are getting as 19. We'll check whether 19 is less than or greater than the base. Here the base is, we are dividing with the base 2. Okay, so division 2. 19 is always greater than 2. So furthermore we will divide the number. We'll take 19 and we'll divide it. We'll get quotient as 9. Now we'll check once more whether 9 is greater or less. As it is greater, we'll divide furthermore 9 number. So that number is divided by 2 and we'll get quotient and remainder. The quotient here we are getting as 4. So still we'll check whether quotient is less than divisor or not. So here it is greater. So we'll divide furthermore 4 by 2 and we'll get quotient as 2 and remainder as 0. Okay, so we are dividing 2 by 2. That 2 by 2 will be divided as it is equal to, it is not less than, or it is not, it is also not greater than, but it is equal to. So we'll furthermore divide it to 2 number by 2 and we'll get number as 1. So we will get number as 1. We'll check whether this 1 will be divided. To check we have to see 1 is less than, so it is less. We cannot divide it. If we cannot divide it, we just have to put that 1 in the remainder and quotient as 0 and we have to stop the process. So now the answer will be taken from MSB to LSB. So here as you can see, MSB number, the last value is 1, remainder, after that it is 0, after that it is 0, after that it is 1, after that it is 1, and after that last value is 1. We'll take the answer as 100111. This is what decimal to binary is. The next type of conversion after decimal to binary is, here the source is decimal and we are just changing the destination part. In the previous thing we have taken decimal to binary. Now here we are taking decimal to hexadecimal. So here we'll take the number as 35. Now 35 will be taken in the division part and here we have to change it to the hexadecimal. So we'll divide the number by 16. Okay, so 35 is divided by 16 as it is greater, so we'll divide it. We'll get quotient as 2 and remainder as 3. So we'll take 2 number to divide it, but it is less, so we cannot divide it. We'll put quotient as 0 and remainder as 2, and we'll get the answer as from MSB to LSD. So MSB to LSB, as you can see, 2, 3. So we'll get an answer as 23. Next type of conversion after decimal to hexadecimal is decimal to octal. So here we'll take an example. Here the decimal number we are taking as 461. So now we have to divide this 461 with the base 8 because we are converting decimal to octal. So 461 will divided with the base 8. We'll get quotient as 57 and remainder as 5. Now we'll have to check whether this 57 can be divided or not. As it is greater than 8, we will divide it and we'll get quotient and remainder. So here we are getting quotient as 7 and remainder as 1. Now we'll take the number 7 and we'll see whether it can be divisible or not. But it is less than, so we cannot divide it. If we cannot divide it, so we'll put quotient as 0 and remainder as 7. Now we will count the number from MSB to LSB. As you can see, MSB value is 7. Then we are having 1, then we are having 5. So now your answer in octal will be 715. Okay, moving forward, the next type of conversions is binary to hexadecimal. Now here, the most important thing we have to remember here is there is no point or there is no division or multiplication involved in binary to hexadecimal. As we know, hexadecimal is with the base 16, binary is with the base 2. So here the technique involves we have to convert. We have to split the binary numbers in 4 bits. Okay, so that thing we will take it as division, but not in terms of mathematical division. We will divide the numbers in group of bits. So that group of bits will always start with the LSD, that is least significant digit, and moving forward till MSD. Okay, so here as you will divide it, the last 4 digit, that is 1, last value is 1001. That 1001 will be first, it will be separated out. So here as you can see 1001, first part. After we will divide, moving forward after 101101, that is 1, then we are having 0, then we are having 1, and then we are having 1. So we'll have 1101. The next part. Moving forward after 1101, we'll have 1010. Okay, so that we will take as 0101 if we are reading from MSD to LSD. If we are reading from LSD to MSD, it will be 1010. Okay, now these are the 3 parts that we got after dividing the binary number. Okay, so this now will be converted into hexadecimal. So 4 bits will be taken individually as hexadecimal numbers. So we'll get 3 numbers as hexadecimal. How? The hexadecimal include the first number as 0101, which gives the number as 5. Then we are having 1101. So that number is given as D. The next is 1001. That the number is represented as 9. So we'll get the number as 5D9 with the base 16. This is what binary to hexadecimal is. The next is binary to octal. Now, in binary to octal, we have to once again take an example with the binary number. So here I am taking the binary number as 10111100. So this is my number. Now we have to divide the same technique which we are using in binary to hexadecimal. But there we were dividing the number in 4 bits. Here octal includes 3 bits. So we will divide this number in 3 bits. So 3-bit division we will take it. We will start with LSD, that is least significant digit. The least significant digit includes 001. So 001, the first part. The next part after this is 111. So we'll take 111. The next is 101. So we'll take 101. Okay. Now these are the three parts that we got as division in 3 bits of a binary number. Now we will convert this 3 bit into octal value. So we'll get octal value, the first value as 101, that is 5. After 5 we are getting 111. 111 is represented as 7. And the last value, that is 100, that is represented as 4. So we'll get an answer in octal as 574 with the base 8. This is what binary to octal conversion is. After binary to octal, we are having next type of conversion as hexadecimal to binary. The technique which we are used in binary to hexadecimal was division. Okay. In division, we were taking the number in 4 bits group. Okay. So here the same thing. We were dividing it. Here we will merge it. Okay. So how we will take? First of all, we will take the hexadecimal value. The hexadecimal here I am taking an example as 5C with the base 16. Okay. So that I will expand it, because there I was dividing it. Now here I will expand it. Now how the expansion will take place? I will take the expansion in 4 bits. Here only I have taken 2 bits. 2 numbers, that is 5 and C. So here one number will be represented by 4 bit. So the first bit, the first number is 5. So that will be represented in 4 bit as 0101. Okay. The next bit is C. So that C is represented in 4 bit as 1100, as the number C is 12. So 12 is represented in 4 bit as 1100. Now we will just merge and will keep the value. Okay, so that we will see binary as the first value 0101, first value, and after this is 1100. Okay, so this is what hexadecimal to binary is. Same thing in octal to binary. We'll take an example, or we'll take the number in octal. In octal we are taking here example as 43. So here 43 is represented with the base 8. That 43, what we will do? We will expand it. In how many bits? So 3 bits. So first number is 4. That 4 is represented in 3 bit as 100. After 4 we are having 3. So that 3 number is represented as 011. So 011 and 100. We will just merge and will keep it, and that number will be our binary number. So here the binary number will be 100 and 11, last 011. So this is what octal to binary conversion is. After octal to binary, the last 2 conversions we'll study is, the first is octal to hexadecimal. Now, the octal to hexadecimal, there is no technique. We just have to understand, or we have to merge the techniques that we have learned so far. Okay. So octal to hexadecimal includes the 2 techniques combination. Okay. So the first thing what we have to do is we have to take the octal number. So in here we have taken the octal number as 456 with the base 8. So this is our question. Now this we have to convert to hexadecimal. Okay, so how we will do it? We will take the expansion of this number. So how we are taking the expansion in binary of octal? That is 3 bit. So 456. 4 is represented in binary as 100. 5 is represented in binary as 101. And 6 is represented in binary as 110. So this is what expansion of a octal to binary. So now the number is represented in binary. Okay, we got the number in binary. Now we'll take this binary number and we will divide, or we will take the binary to hexadecimal expression or the conversion. So how? We will take, first of all, we will represent this number in binary. So this is represented binary as 100, 101 and 110. So this total number has become as a binary number. Now we'll take just binary to hexadecimal conversion. What we were doing in hexadecimal to binary, we were grouping, or we were dividing the number in 4 bits. Okay, so we'll take 4-bit division. Now this 4-bit division here will include last from LSD, that is 0110, 0110, after that 0100, and the last value that we got as 1. Now 1 will not be in 4 bits, so we will add 3 more bits in front of it and it will become 4 bit. Okay, so we'll got the number here in hexadecimal as 3-digit number. So that is represented as 1, that is 0001 is represented as 1. 0010 is represented as 2 and 1110 that is represented as E with the base 16. Okay. Moving forward, the last conversion is hexadecimal to octal. Now hexadecimal number we are taking here as an example as 4DF with the base 16. The same thing we will be studying as hexadecimal to octal. In middle it will come as binary. So how we will represent? The first part includes hexadecimal to binary. How we are doing hexadecimal to binary? We are taking the number and we are expanding it in 4 bits. So we'll take the expansion in 4 bit number. After expansion, the number has become binary. Okay, the number is represented in binary as it is given. Okay, after binary number, what we will do? Binary to octal. So we'll take division of 3 bits, the same number. Okay, so that 3 bits here, as you can see from the last 4 bit, from the last 3 bits, we'll start with the conversions and just we will put the values and we'll take the octal value of the divided values and we'll get the answer. So this is what hexadecimal to octal conversion is. And here everything is over in number system. Thank you.